a second, and there you are, in 50%, 100%. And I think that we are already on live. So thank you so much, everyone, for joining today. Really appreciate all your efforts that we have been doing all these 2 months. I'm glad to present you the Fake News Detector Challenge for LATAM. Here, today we're going to have the best percentage of all the times for the 3 chapters: Mexico chapter, Colombia chapter, and San Salvador chapter. We're pretty welcome to introduce all the following participants. So today, the main task leaders will present about this challenge. So could you please introduce yourselves so that we can go forward with the presentation and so forth?
So, hello everyone, this is Andres Pita. I'm a data scientist and I worked on this as a machine learning engineer. So I'm very happy to be here presenting this project. Brandon?
Yes, hello, my name is Brandon Copeland. I am an ESL teacher by trade. However, I'm also an aspiring data scientist. This is my first Omdena challenge. I'm happy to be here, and I certainly would like to thank all of the Omdena sponsors for allowing me the opportunity to participate. Thank you very much, and it's a pleasure to meet you all.
Thank you so much, guys. Really appreciate it. Also, to let you know, well, I'm Mario Rodriguez. I'm the Mexico chapter lead. I'm the one that try to guide everyone in this project. So really a pleasure to have you here. And it was amazing to have all the efforts in this challenge as well. So I'm going to share my screen. Please let me know when you can see it. Okay.
Okay, we can see it now. So,
Excellent.
Yeah, thank you, Mario. So again, thank you very much everyone for coming to this presentation. Today the team is gonna be presenting about the politics fake news detector in Latin America, which is a project that we have been working on for the past 2 months. We're really excited, but before presenting, can you move forward, please, Mario?
Absolutely.
To the next slide. Yep. But before presenting, I would like to introduce to you the team that worked on this. So for Omdena, for the Mexican chapter, there were 8 collaborators that supported and worked on this project. The one on top left is me, Andres Pita, and then we have Brandon Copeland. But we also have Gauri, Isaac, Gary, Ibrahim, Victor, and Army Elin, who worked very hard on this project, on all the process of creating this fake news detector for Latin American news. Next slide, please. We also had a few mentors and speakers. No, the previous one, please. Yeah. We also had a few mentors and speakers that supported us with technical issues, like Anel, who supported us with data gathering and taught us how to collect the data from news articles. And we also had Abhishek, who supported us with topic modeling and modeling in general. Next slide, please. And last but not least, we have the support of Data Engineering LATAM, which supported us with the data labeling tasking, which I'm going to be speaking about in a moment. So we have Juan Carlos, we have Eugenio, Gilberto, and Ramon, who supported us with this portion. So yeah, before starting, I just wanted to appreciate all the work that people put into this project and all the efforts that were made for this. Next slide, please. And now I'm going to start talking about the problem. So please, next slide, Mario. And yeah, like the more popularity that the social media gains, the more we're going to see malicious actors are going to be producing disinformation and misinformation for influencing the political environment. So you have seen this in a few examples like Cambridge Analytica, in which misinformation and disinformation influence voters to make their decisions in terms of the electoral candidate. So this information and misinformation is very important to tackle because it's gonna create and it's gonna change the political environment of certain countries. So that's what we decided to start creating this model. This is where data science come, and we can approach this as a data solution in which we can identify and determine which news are fake or not. In our project, we decided to do this for fake news articles in Latin America, but more precisely in Colombia, Mexico, and El Salvador. Could you move forward, please, Mari?
Yeah.
And then this is where our first challenge came, which is the data collection portion. Could you move forward, please, Mari? As mentioned, this was the first challenge, and we were at a point in which we had to decide how to get the data for fake news. Could you move a little bit forward just to see the text, please, Mari? No, yeah. And this is when we decided to use scrapers and Twitter's API to collect news articles and tweets because they are generally publicly available and easy to retrieve. So we use these tools to extract around 3,000 tweets and articles, from which we have 1,500 tweets and around 1,500 web articles from 2013 to 2022. We created this data set like this just to have a balanced data set between news articles and tweets. But tweets are much easier to collect compared to web articles. Next slide, please. However, when we were collecting this data, we didn't have any indications of whether these articles were fake or not. So this was the second challenge that we had for the news articles. We were at a point in which we had to see how can we assess these articles in order to see whether they're fake or not. Next slide, please. And this is where the second task came in the project, which is the annotation task. For this, next slide, please. Yeah, the principle of this is how will we define that web articles or tweets are fake or not. Next slide, please. Okay. And for this, we decided to take a two-step approach in which the first step was creating a low performance model. In a few words, this low performance model was a generic model created from another data set of Spanish news articles that was unrelated to the news of Mexico, Colombia, and El Salvador. This low performance model had a recall of around 64%, which means that it's not, as the name mentioned, it's a low performance model. But the approach we decided to take with this is to use this for having an indication of whether the article is fake or not. And then we moved on to the second stage of the annotation process, in which we one by one corrected the articles, corrected the annotation given by the low performance model, using a 7-question framework to correct these annotations. So basically what we did here was creating this feedback loop in which we have a low performance model, then we corrected the model, and then we use these corrections to create a better performance model at the end of the project. Could you move forward, please, Mari? Thank you. This is an example of the 7-question framework that we created for assessing whether the news articles were fake or not. So we have a few questions that we made ourselves in order to assess the articles. The first one is the information exaggerated? Do you see any language that's exaggerated in the news article? The second one is the source of the data missing? Are the article writers omitting the source of the data from which they got this article? The third one is the article source a reliable media outlet? So some of the media is known for being a huge producer of fake articles. So this question was directed to this. The fourth one is it showing up in fact-checking web pages as fake? So we did a quick Google search just to make sure this information is fake or not. And then another example is the article omitting data. So whether the article is kind of like misinforming by not showing the important data for this related news. If the majority of these questions are answered by a yes, then we consider the articles as fake. And this is how we corrected the previously annotated articles annotated by the low performance model. Next slide, please, Mario. For this, we use a tool called Labelbox, from which, thanks to Omdena, we have permissions to use. And we were able to annotate, and yeah, thanks to Data Engineering LATAM, we were able to annotate around 1,000 web articles and 1,000 tweets. This means that we, like, given the limitations of the number of people working at the project, we were not able to annotate 1,000 tweets and articles. And at the end of the day, we ended up with a distribution of around 2,000 true articles and around 1,000 fake articles. So that's what we decided to use for the modeling stage of this process. Next slide, please, Mario. Yeah, and then I'm going to hand it over to Brandon to explain a little bit about the modeling portion of this project. Thank you very much.
Okay, thank you very much, Andres. Mario, if you could move forward just one slide. Okay, as you are all probably well aware, modeling sometimes has and presents its own challenges. What I did was I took a three-step, or I would have to say three-phase approach to trying to model based on the information and the data set that we were able to finally create. I started first by using a deep learning approach with LSTM, long short-term memory. And when I was finished producing this particular model, unfortunately, it did not have the accuracy that I wanted. Originally, it started out with around 69%. And as the stratified data started to change and we started to modify it with upgrading tweets and web articles, it still wasn't producing the accuracy that was necessary. Originally, we were hoping to get at least a baseline of maybe 75% accuracy, and that just wasn't happening using the deep learning model. Some of my other colleagues also tried using other approaches. My colleague Isaac, he used Roberta, which also did not produce the accuracy that we were hoping for, also roughly around 64 to 69%. So after that, I decided to switch gears just a little bit and see if we can use some more traditional models in order to be able to put together something that was a bit more accurate. So what I did was the second notebook that I started working on, I put together, I would have to say maybe 4 or 5 different metrics, including logistic regression, gradient boosting, random forest, decision trees, extra tree classifiers. And I did so using both sklearn and also a low code AutoML to see if I can get any type of, better metrics. So the second notebook that was created, you can actually see here on the screen the percentages with precision, recall, F1 score. And you can see overall, we're looking at anywhere from 63 to 65%, which we decided was definitely not the metric that we were going for. We needed something that was going to be a lot more accurate. So obviously the logistic regression was not what was going to work in this particular case. So after which, what happened was I went back and created a third set of notebooks. This time I decided to try some ensemble methods, which greatly improved the overall accuracy when it came to performance, up to around maybe 81 to 82%. But of course, I thought that, if there's an opportunity to achieve better accuracy, then perhaps we can do that. So in that particular instance, I turned to Mario and some of the administrators at Omdena to see if we can find a way where we can train a little bit more quickly. And we can do it using a Google Colab Pro account. Omdena was gracious enough to allow us that opportunity. And with the help of both Mario and Abhishek, we were able to get the credentials for a Google Colab Pro. in which we started to train some of the later models. So Mario, if you could just go to the next screen. So after we had the opportunity to upgrade our Google Colab account, also I added some other algorithms just to see whether or not we can achieve better accuracy. And I finally ended up finding that gradient boosting, creating a gradient boost classifier, provided the best accuracy overall between all of the models, and that even includes stacked models. So gradient boost to the rescue. What you're looking at here on screen is the metrics of the highest performing notebook. As you can see, we're looking at around 82 to 83%, which was a complete 20% jump from logistic regression. So I was happy that, we were able to increase the accuracy. Now, moving forward, I'm pretty sure we can probably use some other techniques that can also help with the accuracy, but being able to perform at about 82 to 83% accuracy was probably the best metric that we had amongst all of the models. Of course, once we did the final test runs, we were able to also put some of these statistics into visualizations that we've shared in the GitHub account, which perhaps maybe you'll have access to a bit later. But I did want everybody to have the opportunity to just be able to see that we were overall able to increase the final model accuracy up to about 82 to 83% accuracy. So I'm fairly happy with that, given the fact that, we would have liked to have had more time, but I think that's pretty phenomenal that we were able to achieve that in just 2 months. So, and that's pretty much all that I can say at this point regarding the modeling. I would love the opportunity to continue working on this to see if I can improve metrics. But for now, I think 82 to 83% is okay. All right, so Mario, if you could just move to the next slide, I'm sorry. All right, so now the live demoing is going to be done by my colleague, Andres. So Andres, if you'd like to start talking about some of the demoing, then of course I'll pass it back to you.
Thank you, Brandon. That's an amazing work. So Mario, could you open the app, please?
Absolutely.
Yes.
Here you are.
Yes, so for deploying the model, we use a Heroku app with Streamlit to being able to present the content on the model. So for this, we created a 6 pages app, and the first one is the about the project page. This page has a small description of the project and what we have been mentioning before. The next page is the dashboard page. If you could click on that, please, Mario. Yeah, thank you. So the dashboard page shows a few statistics about the data and the data set and the articles that we use for modeling. So this is a small summary on the statistics. Next page, we have the fake news page. If you could click on that, Mario. And this one is for reporting the fake news, reporting all the articles, sorry. So for this, we created like these 3 filters. So you're gonna be able to filter down by date and see which articles are fake or not. So here are a few examples of that. And then, yeah, you could click on the different dates and see how it changes. Showing on top the source of the article and also the type of news that we are talking about. So here we have true articles and fake articles. Thank you, Mari. Next page is the try it out page. Yeah, you can filter by that. Yeah. Thank you. Next page is the try it out page, and this is more for transparency and for using the model and explaining how to use the model. So here we're gonna have a text box in which you're gonna be able to paste the news article. And then, yeah, you can write basically anything there and then see how this is being predicted by the model by clicking at the predict button. So maybe if you could type anything there, Mario, just for an example, and then click on predict. And yeah, this app is gonna throw the results of the prediction at the bottom. So here you're gonna be able to see that the sample that Mario created is true. Next, we have the correction page. And this one, yeah, based on the principle that we want constant improvement of our indicators and our annotations, this page was created for correcting the news articles that we had in the data set. This is still something that in future work is going to require more thinking as to how the framework of this is going to be approached, like what type of news we're going to be correcting, and how, like, which type of users are going to be able to use this, whether it's a political advisor or if it's a data advisor. And yeah, this page is just created for constantly improving these indicators. On the last page, we have the project team page, in which we're showing all the collaborators of this project. Yeah, that's everyone on the team, and a special thanks to Mario for leading this project. And then, yeah, we can go back to the presentation, please. And that's a live demo. Happy to answer more questions if there's any more questions moving forward. And last but not least, we created this slide for the future work, just to kind of hint at what we think should be a few things that could be improved for future iterations of this project. So if you could move forward, Mario, please. And one of the things that we said at the beginning of the presentation is that this data set is narrowed down to Mexico, Colombia, and El Salvador. But because this is a Latin American project, I think one of the things that could be improved for this is expanding this data set to more countries in Latin America. The second thing that we think it's important for this is using more state-of-the-art models for increasing the accuracy and the recall of the model. And this is important because in machine learning, every day new models are coming in, and then we can improve and get a better accuracy on the prediction. Yeah, the third future work that we think it's important is data labeling open for all Spanish speakers, and this kind of goes hand in hand with the correction page. So I think this should be an open source tool in which people are going to be able to assess and correct the articles and the annotations of the articles for better performance of the model. Again, about the correction framework, I think it's important to expand on this and see which type of people are going to be able to use this, because day by day new information is coming in, and then you're going to be able to assess the news from a different point of view when this information is coming in. The two last points are the automation and integration, and also plugin creation. So I think this could be a plugin that would be constantly that would be used constantly in your browser. It's gonna use real-time news to assess them and to annotate them, just to make sure you are able to know whether the article you're reading at the moment is fake or not. I think that's everything that I wanted to say today. Thank you very much, everyone, for being at this presentation. And now I think we're going to open for questions.
Yeah, thank you so much, Andres. Something that I would like to add to this slide is that, well, in order to get this project into the next level, apart from the web scrapping and the plugin, we may have to take into consideration many stuffs in particular. For instance, let's say the place and the date that we will have in the text that is being consulted, or the Twitter or the website, so that we can consider, for instance, the sample that I made, that today is going to be sunny. We were based on the 3 countries, Mexico, Colombia, and San Salvador. But since it's not referring our current location, some of the things that have to had to be concreted in maybe in the next iteration is like taking into consideration these kind of details, because it's going to be important, since the Twitter text or the website to be analyzed will need to take into consideration. That's why we also are going to need the topic model analysis and clustering in referring to this kind, so that later, instead of mentioning what is true or fake, maybe we can say this text, this new, or this Twitter may have like a percentage of veracity in this kind percent with all the further statistics. So from my point of view, I believe this is going to have a great impact for further analysis, further research, and also for further implementation. So I don't know if some of our team would like to add some comments or any other discussion.
Yeah, with respect to more state-of-the-art models, I would definitely agree there. And I would hope that in the future, this could actually spread to more countries, more Latin American countries, and perhaps maybe to even other language families. I'm noticing, or I've been reading as of late, that perhaps maybe using implementations with transformers, other frameworks would definitely increase accuracy. So perhaps maybe going forward, if we can maybe evolve some of our modeling a little bit more, have a little bit more time to work on it, I'm sure we could probably be able to increase our accuracy and have something that is viable for political analysts, people who are doing other types of research. So hopefully that can happen in the near future.
Absolutely, I believe so. The same here, since some of the state-of-the-art models also like the transformers will need a lot of amount of data, will need a lot of amount from other countries, and some of the important parts is like automating the part of trying to level the data, or also trying to check the veracity in this case. So many of those stuff needs to be analyzed and give a further iterations in the next parts of the projects. So to let you know that to all the community, we'll be handling the next session in here internally between the chapters to see how we can advance. So so only to let you know that we'll be taking all this discussion that we are making for full development. I'm happy to have other people in this project, where we will announce this announcement sorry, in our official websites on Omdena local chapters in Colombia, San Salvador, and Mexico chapters. We're happy to contribute with everyone else. So don't know if in YouTube Live or any other social media would like to ask any questions. We are pretty open ears to listen to your questions and then give a follow-up. Or even if some of the current participants would like to add their comments too. Happy to hear it. Okay. So far, so good. I believe that we don't have yet any response from the live chat. And anything else? Don't know if the current participant would like to add their comments right now. Okay. Meanwhile, I would like to only mention that we're going for all the all the viewers that we have here. On April 30, we will have Omdena Demo Day. So if you click, well, if you go forward to Omdena website and look for Omdena Demo Day, we're going to have a network events that are going to be pretty useful, where also this event will be discussed. Well, this topic, this challenge will be discussed, and you have the opportunity to network with everyone else with all the other chapters and members. So I see that we don't have any other further questions in the live chat. So I'm going to move forward, and only first of all, I would like to congratulate to all the first of all the participants, all the 8 participants that we have here in the early beginning of the presentation. Then special thanks to Andres, to Brandon, that had a great leadership in their own task and had the opportunity to give follow-up to every single link, and also to the other 6 participants that make this possible. And also a special thanks to the data engineering community that gave us the opportunity to launch this big announcement to get all the labelers that made the models to get the accuracy that we had currently. And finally, special thanks to Levelbox, our current partner in making all the leveling in this project possible, and all collaboratory pro as well. So really appreciate all your efforts so far. In for the case that you would like to contact us, please feel free to get us through Omdena or community in Slack, and also through LinkedIn. So a pleasure to have you here, and looking forward to see you in further challenges. And also a special thanks again to all the participants. Really enthusiastic project, and really looking forward to see you next time. Don't know if some of you would like to add any comment or anything else.
Well, I mean, it was truly a pleasure working with everybody. This was a great experience. I would love to be able to, consistently contribute to these projects. And, I'm surrounded by fantastic data scientists. Mario, I'd like to thank you for having me as a participant in the project. I would like to thank Omdena, all local chapters, Andreas, Victor, Isaac, Armelin, and everybody who helped out with the project. Ibrahim, thank you guys very much. You definitely made this worthwhile. It was a pleasure.
Yeah, thanks everyone for all the work that you put into this. It's been a really exciting opportunity and a learning opportunity as well. Army, I think, is saying that we should take a photo. Yeah, I think that if anyone, yeah.
Give me a second then to take a photo for everyone that is hearing in the chat.
People could turn the camera on.
Yeah, give me just a second. I'm going to stop sharing the this thing and unpin you so that we can see everyone here. Give me just a second. Remove pin. Okay, give me just a second. Immersive. Gallery. There you are. We are right now here. Absolutely. So yeah, definitely. There you are, everyone. I really appreciate all your efforts over here. Thank you so much. So here are all the participants that were behind the screen, in the background and everything. So was really happy to see you, and well, we'll see you continually in every chat, in every meeting, and then for the ones that in Mexico and everything, we will have to see each other in a physical meeting. So really happy to see you all. Yeah, definitely. So Thank you so much. I'm going to get off the live in a case. So in case that you would like to add any comment here in the live screen at the time. Yeah. So thank you so much for all the viewers so far. This is the end of the live stream. Really appreciate your time and see you next time.